All right, we're still in 7.5. Now we're gonna have to start maybe using some identities along with our circle. So if I were you, I'd have out your reciprocal, even, odd, quotient, Pythagorean identities, and then I'd also have out your circle. Okay, so let's say we have 2 cosine squared theta plus sine theta minus 1 equals 0. Okay, first you'll probably notice that I see a cosine and I see a sine. I can't work this problem yet because I have to be able to factor it, and to be able to factor it, I have to have all the same word, like either all cosine or all sine. So, darn. Let's see here. The only thing I can plug in for sine is maybe 1 over cosecant, and that helps me not at all. But let's see if I notice what 2 cosine squared theta minus 1 is. I don't think it's quite one of these reciprocal or Pythagoreans, but it is a double angle identity. See, 2 cosine squared theta minus 1, 2 cosine squared theta minus 1. What the poo? What the poo? Yeah. Okay, so this sucker is equal to cosine 2 theta. But let's see, if I plug in cosine 2 theta for what I underlined, so if instead of what is underlined, I put cosine 2 theta, it doesn't work because I still have mismatching words. I need sine everywhere. Okay, so this 2 cosine squared theta minus 1, it's equivalent to all 3 of these forms, all 3 of these. So technically, I can plug in 1 minus 2 sine squared for 2 cosine squared theta minus 1 because they're all equivalent. So I'm going to take what I underlined and I'm going to plug in 1 minus 2 sine squared theta. So no more of this. Instead, I'm going to plug in 1 minus 2 sine squared theta. Okay, and then I still have this plus sine. Okay, now that it's all the same word and I have a squared and sines, I can put it in order and factor it. So I'm going to put the squared thing first. So the squared sign first, then the regular sign, and very lastly this 1, and it's a pretend positive, so plus 1. Okay, now I'm going to factor it, but before I can do that, I see this yucky negative on the front. Let's divide everything off by a negative, or say GCF is -1, because otherwise this won't work out. So I'm going to put -1, open parentheses, divide everything by -1. 2 sine squared theta. Sine divided by -1 minus sine theta. 1 divided by -1 equals 0. Okay, now you can McAdoo this. We slap the sine thetas on front because that's what's squared. We draw the division bar. We divide by what's on the front of the squared, 2. And remember, we have to add up to this middle number, -1. And we have to multiply to the first times the last. 2 times -1 is -2. So what 2 numbers could branch off from this -2 that could also add to -1? How about -2 plus 1? So let's put these in the parentheses. And it's all equal to 0. Okay, so now we have -1 parentheses sine theta minus 2 divided by 2 is 1. Parentheses. Here we can throw the 2 up, but eventually we're going to equal it to 0 anyway, so I'm just going to keep it like that. Sine theta plus 1/2 equals 0. Then you set each little chunk equal to 0 and solve, like what we did in 7.4. Okay, so I'm writing each little chunk equal to 0. And this -1 equals 0 just gets trashed out because there's not a theta there to solve for. This sucker, remember you add 1 to the other side, so you get sine theta equals 1. You throw an inverse on it, it cancels, blah, 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 so you get sine theta. Sorry, you get theta equals sine inverse of 1. Then we look on our circle and we say sine means y. Y is 1 when we have 3 pi over 2 equals theta. And this problem at the very beginning, I forgot to mention it, but it said over the interval 0 to 2 pi. 0 to 2 pi. So I have the answer pi over 2. Now I have to add 2 pi in. Okay, and then I don't have to divide by anything or multiply by anything like we've done in the past because theta is by itself. So I just say theta equals, if I plug in a 0 for n, I get pi over 2. If I plug in a 1 for n, I get pi over 2 plus 2 pi, and that's over my interval. So it's just pi over 2 for sure. And then y'all can finish the rest of the problem on your own. Okay, let's do another one. At least start it. This one, it looks weird. Cosine 2 theta minus 7 cosine theta plus 4 equals 0. What the? Okay, so first off, I see that all the words are the same, cosine, cosine. And I could factor this if this cosine 2 theta was something like, instead of cosine 2 theta, if I had cosine squared, I could totally factor it like I just did the last problem. So let's see if I can plug in anything for cosine 2 theta. That's an identity. So let's look for cosine 2 theta. Here it is. And it has 3 things I could plug in. But we want to keep the whole cosine theme going on. So I just want to plug in something with cosines. So I'm not going to plug in this first equation because it has the sign. I'm not going to plug in this last equation because it has the sign. Hey, Birdie. I'm going to plug in this middle equation because it has the cosine squared. That's what I need. So instead of cosine 2 theta, I'm going to put 2 cosine squared theta minus 1. Okay, good. So instead of this cosine 2 theta, I put this sucker. And then I still have minus 7 cosine theta plus 4 equals 0. Now we're going to combine like terms so we can factor. So this -1 and this 4 make 3. So we have 2 cosine squared theta minus 7 cosine theta plus 3. Whoops, no parentheses, equals 0. And then now you can factor it, where we put cosine thetas at the front. We divide by what's on the square, 2. We have to add to the middle term, -7. We have to multiply to the first times the last 6. Why is it not focusing? Okay, and the only thing that I can think of, why is it not focusing? The only thing that I can think of is maybe -6 and -1. So let's plug that in. I'm going to have -6 minus 1. And this makes cosine theta minus 3 and cosine theta minus 1/2, and it's equal to 0. So now we're going to equal each thing to 0. So cosine theta minus 3 equals 0. Cosine theta minus 1/2 equals 0. Okay, let's solve for theta. For this first one, you have to add 3, then put a cosine inverse. So theta equals cosine inverse of a 3. The second one, you have to add 1/2 and put a cosine inverse. So you get cosine inverse 1/2. Okay, let's think about this. Cosine is when x. Okay, so we're looking for when x is 3 on the unit circle. That's never gonna happen. So this answer is out. Because remember, at the beginning of this problem, I forgot to tell you, but it said 0 to 2 pi. It said write all the answers from 0 to 2 pi. As in from the unit circle. So this 3 is not from the unit circle, so this gets scratched out. So you just have to finish this one. So I'll let you finish that on your own.